Good morning, guys. It is April 28th, 2020. Welcome. So, today we're going to talk about the power of factored form polynomials. So, you already know this, but we've talked about it last week, but I want to really make sure that you understand this point and how in solving an equation, factored form is the way you want to go because you get to see some things, you get to use zero product property. So let's take a look at this. This will be review. If you've kept up, remember, make sure you have your notebook out, take some notes. Your notes will help you when you're working on your problem set. So I have an equation, 4x squared equals 10x. If I asked you to solve this equation a couple weeks ago, you might have got lucky. You might have figured it out by guessing and checking, but there's a likelihood you wouldn't have. So let's look at this. Remember, when we're solving polynomials, if we could get the polynomial into factored form and set it equal to 0, we could use zero product property. So take a look at this. I'm going to subtract 10x from this side. Remember what I do on one side, I need to do on the other. And I have this, 4x squared minus 10x equals 0. So the one way we have learned to factor is by dividing out or factoring out the greatest common factor in both of the terms of the polynomial. So if you look here, greatest common factor is, what number goes into 4 and 10? That's 2. So I'm going to factor that out, which is the reverse of the distributive property. Now I got to think about the variable part. I know the first term has x to the second power, the second term just x. So I know there's at least an x in each of these. And now I'm just going to do the reverse distributive property. What do I need to multiply 2x by to get 4x squared? That would be 2x. And what do I need to multiply 2x by to get negative 10x? That would be minus 5. So, because of zero product property, I have two pieces here. This term times this term equals 0. That means either one of those terms or both of those terms have to equal 0. So we're going to set up that equation. 2x can equal 0. Or 2x minus 5 could equal 0. Divide both sides by 2 here. X equals 0. And then on this one, we add 5 to both sides. 2x equals 5 divided by both sides by 2. We have x equals 5 halves. You could rewrite that as 2.5. You could rewrite that as 2.5. But here are my two solutions. X equals 0 and x equals 5 halves. Or 5 over 2 or 2.5. So probably it would have took a long time to guess and check that. So remember, zero product property is extremely helpful in solving these equations. And in order to do that, you have to ensure that your polynomial is in factored form. So, that being said, let's take a look at this polynomial. Can we use the greatest common factor to transform it into factored form? Right now, it's an expanded form. Well, I'm looking at 964, greatest common factor. Is there any number that goes into 9 and 64 evenly? Actually, the only one is 1, and that's not going to help us because if I divide out 1, give me a second here. Let me erase this. If I divided out 1, I would still be left with 9x squared minus 64 on the inside. So I really haven't transformed that. So it's not going to work. So hopefully there's some other tools. And we're going to discover one today. So take a look at this. So our focus question today, April 28th, 2020. We know we could transform a polynomial into expanded to factored form by factoring out the greatest common factor, but does that always work? The answer is no. Sometimes you're not going to be able to find a greatest common factor. So are there other ways to factor polynomials? We are going to see one right now. So let's just take a look at this chart. I'm going to fill it out, and then I want to see if you notice any patterns. So first line, or the first row, we have an A value and a B value. A is 10, B is 6, and I'm just going to fill out the rows here, and I want you to do the same thing at home. So A is 10, I'm just evaluating this, so this 10 minus 6, and then 10 plus 6, just A plus B is 10 plus 6. And then it's A minus B times A plus B. So A minus B, which is 10 minus 6. And actually, I could rewrite this out. 10 minus 6 is 4. 10 plus 6 is 16. So now we have A minus B, which is 4, times A plus B, which is 16. Now, A squared is 10 times 10, so 10 squared, which is 100. And then B squared is 6 squared. It's 36. So if we look at that, it says A squared minus B squared. Well, that's 100 minus 36, and that is 64. Now, I didn't do it yet, but this column over here, this 4 times 16 for the quantity of A minus B times A plus B, 4 times 16 is also 64. Okay, so one thing I do notice is 64, 64. That's one similarity I notice. Let's try it again with 8 and 2 now. So A minus B, which is 8 minus 2, that would be 6. A plus B is 8 plus 2, which is 10. So A minus B times A plus B is 60. A squared is 6, or 8 times 8, which is 64. B squared is 2 times 2, which is 4. And then A squared minus B squared is 64 minus 4, which is 60. Once again, I notice that we have a similarity. And it turns out that let me get the highlighter here. It turns out that the quantity of A minus B times the quantity of A plus B equals A squared minus B squared always. And we can prove that, because if we had expansion boxes, and we did A minus B and A plus B, and we multiply that out, this box will be A squared, this box will be A times B, this box will be negative B times A is negative AB, and B times negative B is negative B squared. If we added them up, these guys are like terms. So AB minus AB is 0. It's gone. They're opposite. So all we're left with is A squared minus B squared. So this being said, A squared minus B squared, if we have a polynomial that looks like that, A squared minus B squared, we know the factored form is always going to be A minus B times A plus B, which is great. Remember, one of our goals here is to be able to factor. And to factor is turning something, a polynomial, in expanded form, like A squared minus B squared, to a polynomial in factored form. Okay, so this is called something. This is called the difference of squares theorem. Think about this. It's called the difference of squares because that's what we have. We have a difference, which is subtracting two square numbers, a squared minus b squared. It will always factor out to a quantity of a minus b times a quantity of a plus b. Difference of squares. All right, let's go to the next slide. So let's think about this. 9x squared minus 64. If I could write that polynomial, this one right here, as a difference of square numbers, I could factor it. So let me think of this. This is how I'm going to do this. And we're going to take this a step at a time, and this often gets complicated, so we will just take it a step at a time. So if I could write that same polynomial is something squared minus something else squared, then I could use this difference of squares theorem to factor it. So this is what I want to do. Take a look at 9x squared. Can I write that as a square number? So what number or what term times itself will give you 9x squared? Well, it turns out, didn't want to do that. Turns out it is 3x. Because think about that. 3x times 3x is 9x squared. What number times itself will give me 64? That's going to be 8. So 9x squared minus 64, I could rewrite it in an equivalent way, 3x to the second power minus 8 to the second power. So this would be like 3x would be my a, so it would be like a squared minus b squared. So my a would be 3x. So remember, a squared minus b squared is the same as a minus b times a plus b. So if we were writing this out, my a is 3x, so I could write it as 3x, and my b value is 8, so minus 8. My a value is 3x. My b value is 8, so plus 8. So that means 9x squared minus 64 is the same expression. It's equivalent to the quantity of 3x minus 8 times 3x plus 8. If I was using this factored form, I could solve an equation if I need to do later with zero product property. So that was a lot. We're going to break it down one step at a time, and today what you're going to be required to do in practice is just one of those steps. So think about what I just did. Actually, when I say what number times itself equals 64, that's the same as saying what's the square root of 64. When I said what number times itself equals 9x squared, that means the same thing as what's the square root of 9x squared? And it's 3x, because 3x times 3x will give you 9x squared. So it says small step number 1. Find the square root of each monomial. Remember, monomial is just one term, so that we could write the polynomial as a difference of squares. So I'll do a couple right now with you, and then you'll do the rest in your work today. So I'm just going to expand this. So let's think about 36. What's the square root of 36? Or how do I write 36 as a square number? That's right. I'm just going to put a 6 in here. 6 to the second power is 36. What about something with a variable? 4x squared. So I'm over here. 4x squared. What's the square root of that? Or what times itself will give me 4x squared? Turns out it's going to be 2x. Let me get a little more. Oh, I'm going crazy here. Okay, so this is going to be 2x. So it's 2x. You know what? I'm going to make that a little bigger, guys, so you could see it. I don't want that to mess you up. So this is going to be 2x. Okay? Because 2x times 2x will give us 4x squared. Let's try something maybe a little more complicated. How about something like this? 81b to the 6th power. Well, what times itself will give me 81? That's 9. And then what times itself will give me b to the 6th power? Well, it's got to be b to the 3rd power, because b to the 3rd power times b to the 3rd power will give me b to the 6th power. So it's 9b to the 3rd. So the way you write that out is this. I'm going to make it 9b to the 3rd power to the 2nd power is 81b to the 6th power. So today, that's the first step of this. That's the first step of using this difference of squares theorem to write a difference of squared in factored form. So I want you practicing this today. So in your problem set, I'm going to give you some monomials, and then I want you just to write them as a squared number. So let's try one more, maybe one that's a little more difficult. 576 x to the 2nd power. Y to the 4th power is e to the 6th. How do I write that as a squared number? Or that's like saying, what's the square root of 576? So I'm going to ask Siri to help me out. Hey Siri, what's the square root of 576?
The square root of 576 is 24.
There we go. So that's 24. That means 24 times 24 gives me 576. Now, let's think about x to the 2nd power. What times itself will give me x to the 2nd power? It's just x. What times itself will give me y to the 4th power? Well, it's y to the 2nd power, because y to the 2nd times y to the 2nd, we just add the exponents, is y to the 2nd power. You know what? I'm going to write it above because we don't have space in there. So 24 x y to the 2nd power. And then z to the 6th power. What times itself will give us z to the 6th power? It's z to the 3rd. And that's all going to be squared. And if you notice, because if you remember your just kind of rules of exponents, notice what's happening here. If you're taking the square root of these numbers, or I'm sorry, not the numbers, the actual variables, you're really just dividing them by 2, right? X to the 2nd power, if I divide 2 by 2, I get 1. Y to the 4th, I divide 4 by 2, I get 2. Y to the 2nd. And if I have z to the 6th, if I divide that 6 by 2, I get z to the 3rd, because z to the 3rd times z to the 3rd would be z to the 6th. All right, guys. Work on this in the chat today. Let me see. Can't see it. I want you to do this as an exit slip. I want you to private message me the answers to this exit slip. So it will be in the chat, and I want you to rewrite 64x squared as a square number, and I want you to rewrite 100x to the 6th y to the 4th as a squared number. All right, guys. Have a good day.